In this video, I will discuss the topic called particle model. Within this topic, there are four subtopics: states of matter, density, energies and state changes, and gas pressure. Let us quickly recall each one of these, highlighting the main content that you will need to know from these subtopics. From states of matter, you need to know that there are three states of matter: solid, liquid, and gas. For each of these states, you will need to know the arrangement, number one. Number two, movement. Number three, force of attraction between particles. So when it comes to movement and arrangement, this is for particles. And when it comes to the force of attraction, it is between particles. In your exam, a question may ask you to describe a state as solid, liquid, or gas. In response to that question, you'll have to write a sentence about the arrangement of particles, about movement of particles, and force of attraction between the particles. From the section density, the first thing that we need to know is what is density. So density is defined as mass per unit. When it comes to density, there is an equation for it, and that equation is density equals mass over volume. Now, density can have number of units depending on the unit of mass and volume that has been used in the calculation. So density can be in grams per centimeter cube, or it could be in kg per meter cube. There's a core practical on density that makes density one of the very important topics for your exam. So let's quickly have a look at the core practical. Any core practical related questions that you come across in exam, my recommendation is, if there is an equation for it, make sure you start with the equation, because the equation will guide you how to structure your answer. In this case, we do have an equation for density, and that is density equals mass over volume. Now, because we are trying to work out the density of given material, we will have to make measurement for the mass, and we will also have to make measurement of the volume. So we can say mass can be measured using balance. Volume measurement is of greater importance in this case, because there are different types of objects for which we may be asked in exam to work out the density. So we can say we may have regular shaped solid. We may have irregular shaped solid. And the last bit is we may have liquid. Now, if it is liquid, it's straightforward. You will use measuring cylinder. If it is regular shaped solid, then you will use ruler. Number one. Number two, you will have to use expression from your maths. For example, we know the formula for volume of cube is length times width times height. The volume of cylinder will be base area times height, where base area is pi r squared times h. So you'll have to use equation. For example, cube or cylinder. If the object is irregular shaped solid. And for this we use displacement method. Knowing displacement method for working out the volume of irregularly shaped object is important for us. The core concept in this case is we will record the change in volume. Now to perform this method, you can use a container. You'll have to fill that container to a known volume. I can say there are two options here. You can use measuring cylinder. You'll say fill it to 50 or 60 centimeter cube mark. And then number two, I'll say add solid. You have to make sure you say ensure fully submerged. Number three, you will then record change in. And this volume will be our volume of solid. Option 2 will be to use another equipment called Eureka can. So you can see, use Eureka can. And again, you'll have to say fill it to the top. Number 2, once you have filled it to the top, then you'll do the same thing. You'll say add solid. But again, you have to make sure you say ensure fully submerged. Then number 3, you will say collect water in the measuring cylinder. So what will happen when you add solid to Eureka can? Water will come out of it. That water needs to be collected in measuring cylinder, and this volume here will be volume of solid. So whether you use this method or this method, the main concept is we are recording the change in volume. On this section, there's one main thing that you have to keep in mind when it comes to the density. Objects with lower density will float on liquid. Now remember, in this case, I'm assuming my liquid has density greater than the object. For example, if I have wood and I place wood in water, wood will tend to float. Why will it float? Because it has lower density than the wood. This is all that we need to know from the section density. Just a quick reminder, this is important. The next section is about energy and state changes. So when you supply energy, you can say energy supplied will be used for two purposes. Number one and second. First one, I can say this will be used to raise temperature. Second option will be to cause state change. when temperature is being raised, we can say energy supplied will increase Ke, which is kinetic energy of particles. In this case, when it is being used to cause state change, then we will say here energy supplied will be used to break forces of attraction between particles. When energy supplied is being used to increase the Ke of particles, then we will say for this section, the concept of a specific heat capacity will apply. On this side, the concept of latent heat will apply. So we now need to know what we mean by word specific heat capacity and latent heat. So when it comes to specific heat capacity, it is defined as energy required to raise temperature of object by 1 degree Celsius, and the mass of object must be 1 kg. So it has three components to it. It is energy required to raise temperature of object by 1 degree Celsius, and the mass must be 1 kilogram. The unit for specific heat capacity is joules per kilogram degree Celsius. On the other hand, when it comes to the latent heat, again, the first section is same. You'll say it is energy required. But this is not to raise temperature. This is to cause state change. To change state of 1 kg object. So it has, again, main concept that you have to keep in mind. The object must have a mass of 1 kilogram, and that's common to both of them. The unit in this case is joules per kilogram. Both these concepts have their own equations. So I can say the amount of energy supplied, which is given by delta Q, is equal to mass times specific heat capacity times change in temperature. Whereas the second equation is energy supplied is equal to M times L, where L is my latent heat. Here C is my specific heat capacity. Now I can rewrite this equation in another format, and that will be energy supplied equals M times C times T final, take away T start. So this is the final temperature, this is my starting temperature. So in exam, there could be two types of questions on the use of this equation. In one case, they may give you the change in temperature that has taken place. So that will be the value of delta T straight away. But sometimes they'll give you the starting temperature and the final temperature. In that case, you will make use of this equation. This equation is important for us because there's a core practical related to finding specific heat capacity of an object. Before I go on to the core practical, we have to look at few bits again from the start of this section number one that you have to remember is whenever there will be state change, it will always take place at happens at fixed temperature. In addition to this, we'll need to know the names of the state changes. So when you go from solid to liquid, that's called melting. From liquid to gas, it's called boiling. From gas to liquid, it's called condensation. And from liquid to solid is called freezing. But you can go from solid to gas in some cases, and that's what we call sublimation. Sometimes it is possible to go from gas to solid, and that is what we call desublimation. Now I can show the same information on a graph. I can say graph. Here I have the temperature, and here it will be energy. Now in this case, I can say 1. So you need to remember this is my solid, liquid, and gas. So when it is solid, liquid, gas, for these three locations, the concept of specific heat capacity will apply. Why? Because the temperature is being increased. For these two sections, the temperature is constant, and that indicates a state change is taking place. So when state change takes place, that's the concept of latent heat. I can say here, this is a state change. I'm not writing the names here for the state changes. We'll have to link that information with that. So I can say quickly here, concept of specific heat capacity will apply. These two sections, the concept of latent heat will apply. The next section is on core practical, finding specific heat capacity of the object. Now when it comes to finding specific heat capacity of the object, like I said in the previous case, if you know an equation for a core practical, make sure you write that equation down, because it will guide you how to structure your answers. So in this case, we do have an equation which is energy supplied equals mass times specific heat capacity times final temperature and starting temperature. So it makes my life easier. All I have to do is I'm going to say record mass using balance. Number 1, I'll say record starting temperature. I'll say record final temperature, both by using thermometer. Recording energy supplied can be done in a number of ways, and it will depend on the setup being used. The most easiest one is using joule meter. Second one will be using E equals P times T, where this is my power and this is my time in seconds. Power has to be in watts. In this case, we will have to make use of stopwatch as well. So you'll use stopwatch to determine the time, how long you have used the equipment that supplies energy. And then if you multiply that time by the power rating of the equipment, it will give you the value of Q. There is another way of finding energy supplied, and that is E equals V times I times T, where V is your PD across heater, I is the current through heater, and this will be your time. So there are three ways that you can work out the value of Q, and that will depend on the setup being used. With this, you have to remember one thing, that the voltmeter will be used to determine the potential difference, and it has to be connected in parallel. In this case, current will need to be determined, and that will be done using ammeter. So here you can say use ammeter in series. Here I'll say use voltmeter in parallel. And finally, if you rearrange this equation, you can say C will be equal to energy supplied over M times T final take away T start, and that would be the standard structured answer for a question where it will ask you to find the specific heat capacity of a given object. The last section on this topic that we need to know is called gas pressure. Now you need to remember the gas pressure, it depends on number one, mass. In other words, I can say quantity of gas. Number two, I can say it will depend on the temperature. And number three, I can say it will depend on volume of space that the gas has. So we just have to look at them. What if you change one, what will happen to other? So for first case, I can say my temperature and volume are constant. And if they are constant, I can then say if my mass increases, my pressure of gas will increase. If my mass decreases, my pressure will decrease. For the second case, I can say my temperature and mass will be constant. This means I'm not going to change them. What I will change in this case will be the volume. So if I increase volume, my pressure will decrease. If I decrease volume, my pressure will increase. Case number three, I'm going to keep my mass and volume constant. And in this case, I'm just going to look at if I change temperature, what will happen to my pressure. So I can say if the temperature increases, pressure will increase. If the temperature decreases, the pressure will decrease. Now for this case, we do have an equation, and that equation is P1 times V1 will be equal to P2 times V2. So we are saying the product of pressure and volume at state 1 will be equal to pressure and volume at state 2 for a given gas, provided the mass and temperature does not change. One last bit on this topic, and then that will be the end of this topic. Something called absolute temperature. Now, absolute temperature is basically 0 K or minus 273 degrees Celsius. This is what we call absolute temperature. At this temperature, the gas will have zero pressure. Number two, the Ke of particles will also be zero. The last bit that we need to know from this topic is our work done on the gas. This is when you compress the gas, and then the temperature of the gas increases. Why is it that the temperature of the gas increases? So we can say when gas is compressed, energy is transferred to the gas particles. What does it do? It increases their internal energy. And this causes rise in temperature. With this section completed, we have now covered the topic called particle model. So we've done states of matter, density, energy and state changes, and gas pressure. Please like the video and share with your friends so that they can also benefit from this material. To stay up to date with the content on my channel, please like and subscribe. Thank you.